now it's just sound. So topic 2 is on reduction and oxidation, and the notes there will follow along. This PowerPoint is on the classroom, so you can see that as well. The I can statements, these are things that by the end of this topic section you should be able to do. So balance single replacement reactions, use mole ratios to predict the number of moles, consumed in a redox reaction. Maybe these words don't mean anything to you, but you'll know what it is soon. Determine the reactivity of metals. Know what an oxidation and reduction reaction is. Know what spontaneous and non-spontaneous reactions are. And then apply principles of redox half reactions to voltaic and electrolytic cells. It's a lot. Okay. So next week, I'll be going through some of this. I don't know if I'll get to it next week when you guys aren't here, but if we do get through this and I have time, we are going to do a lab that's related to this. Voltaic cells are like batteries using chemicals, so we will do some sort of lab along those lines. I'd like to try and do a lab at least once a week with you guys. So if we do it next week, then you'll do it when you come back, right? So whenever you're here, I'll fill in those missing pieces. Okay, so we have a bunch of stuff to figure out before then. So it says compounds and chemical change. It says a chemical reaction is defined as a process in which the chemical bonds of reactants are broken and rearranged. This results in production of a new substance. So remember last week or whatever it was, we talked about chemical reactions. That was this week. And remember there was 5 different things, everything's blending together here. 5 different things that would make up a chemical reaction, or we would know that a chemical reaction happened. Do you remember some of those things? Maybe?
Wait, what?
I think Jason was the one that came up with most of them.
Huh?
So the 5 different things that we know a chemical reaction has happened.
Oh, the way it looks, like the smell,
Yeah, so odor production,
the change in color,
change in color, color change, odor.
Why is that stupid? I think of the one that we were talking about, the green one.
Yeah,
What is
precipitate.
it? Yeah.
So when it forms a precipitate, it's really just a solid at the bottom.
Yeah.
Bubbles.
Yep.
And the last one, talking about temperature. Do you remember that one? So temperature change. So those are the 5 things that we, with our senses at least, can detect that a chemical change has happened. Yeah. So anyway, back to this. It says, although a new substance is produced during this process, atoms are not created or destroyed. This is referred to the law of conservation of matter. So this is a law or a rule in science called the law of conservation of matter. And you've probably heard of it before, maybe. Nothing can be created nor destroyed. So even if even when we die, right, we're not destroyed. Like our body becomes something else, right? We just change forms, right? We just go into the ground, disintegrate, and then the pieces and things inside of us can give nutrients to the soil. It's not like we just disappeared into thin air. Nothing is ever destroyed. Nothing disappears. That's magic, and magic isn't real. Sorry to burst your bubble. That's what that means, the law of conservation. So nothing can be created or destroyed. It just changes its form. What? Okay. So equation involve the same number and types of atoms. They are just arranged differently on each side. So this one shows you CH4 and oxygen give you carbon dioxide and water. So if we were to tally up all the different things or atoms that we have here, we just have carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, right? So there's nothing different. If you have something different, there's a problem. You shouldn't have something randomly show up. It's like, oh, I put this milk in a glass and all of a sudden there's Pepsi in there too. Like that doesn't happen, right? That would be kind of gross. Wait, is that like how you make like floats though, right? Really? Because you have ice cream and
but it's just like
it melts and then you have like milky. I don't like that.
I'm okay with that.
You're okay with that? But not if you just put milk?
I'd rather just have milk though. I don't like the top. I don't like the
Oh,
top and
yeah. That's not a float then. Yeah, anyway. We're sidetracked. Going back to this. So this is what I'm getting at here is that, yeah, from one side to the other in the equation should have the same stuff. It's just changing its form. CH4 is not on this side. It's C is with an oxygen and it's with a hydrogen. Or the hydrogen is with an oxygen. So they're just changing their partners as they move along. Okay? And this is nothing new to you guys. Should be a review on how to balance equations. The last group, cohort 1, I actually went over how to balance equations. So this is really a review to them because I reviewed that with them, and then they're going to do it now. You guys, I didn't review it. Did they know it?
Yeah, they know it first time.
Got it. They took them some time, but they remembered some of the steps, which is good. And you guys will hopefully too. So it says, due to the law of conservation of matter, all chemical equations must be balanced. So we can't start out with 100 milliliters of milk and end up with 50. Where did that extra 50 go? We need to have the same on one side as the other. It's like a balancing act. This arrow is like the middle of the balance, and you're balancing on either side. It should be balanced. You shouldn't have more or less. Okay? So it's giving you a formula here, and it's showing what it is unbalanced versus balanced. What I would like to do is I'd like to do this question.
Okay.
Do you remember how? I'm just going to show you on a different slide. I just need to bring this Zn, HCl, H2, and ZnCO2. What? Zn plus HCl gives us H2 and ZnCO2. Okay, so it gives you the answer on the other one, but I want to show you how we got this. It's not really showing you on that slide how we got it balanced. So, what?
I know what I'm doing.
You know what you're doing?
I remember now.
Okay, so then you can lead us through this.
Line
Hopefully. Okay, so what we see here is, at first sight, maybe you don't notice it's not balanced, but it's not. But we don't need to look at it first sight. My way of doing this, and maybe another teacher's taught you a different way, because Miss Reimer teaches this different than I do, and maybe Steinberg teaches it different than I do, but whatever way you get there, I don't care.
I remember
You remember my way because I taught you since. They learned taught it a different way than Steinberg, and now you got me, so hopefully you don't teach it all 3 different ways. What I always do is, because it's balanced, I always draw a line in the middle, and then I tally up what we have there. So I've got to write down all of the elements that are on each side. They should be the same. We've got Zn, we've got H, and we've got Cl. Okay? On this side, we should have the same Zn, H, Cl. So I normally just write it in the same order, because then it's easier to compare. Now, Kai, since you remember this, what do we do next? So we tally up what we've got at the moment. So how many ZNs do we have on the left?
We have one.
Yeah. How many H's?
One.
CLs?
One.
ZNs on the right?
One.
H's?
Two.
CLs? Oops. Yeah. So, not balanced, right? Our ZNs are balanced, but the H's and the CLs, we started out with 1 and we got 2. That's not possible, right? So we've got to balance it. This is a pretty easy balancing question, because I can already see it. Maybe you can too. But you don't have to. Again, I used to teach in northern Saskatchewan, and I used to teach Chem 30, and I had a student that could look at a really, really complicated like equation, and he could balance it like in his head, like, oh, it's 7, 3, 21, that like he had this crazy ability. I'm like, you're way smarter than me. I can't do that. I need to see it on paper and like solve it like this. So like if you could do that, like go for it. I don't care as long as it's right. But I'm showing you this is how you get there. It's like a foolproof way. Like you're not gonna mess up. Okay, so let's balance something. Which one? H's or CL's? Doesn't matter, right? Normally we leave the hydrogens and oxygens and stuff till the end. That's sort of like our rule. So let's just do the CLs. So CLs, there's 2 on the right, we need 2 on the left. So how do we get 2? What do we gotta add? Yeah, we gotta add a 2 in front of the H or behind the CL. Yeah, how come we don't go like this?
Because it'll just go with each. Okay.
Like, some people would do that, we can't do it, but because that would change the whole composition of HCl. H is a positive, Cl is a negative, that's a balanced molecule, like, we can't just add a 2, then it's unbalanced. It doesn't work that way, okay? What we gotta do is the only thing we can do in these is anything we could ever do is to add into the front. So you guys said it, 2 here, right? Sorry, my CL is a bit off. So if we add a 2 there, it changes our CL to 2. What does it do to our H? Changes it to 2 as well. Oh look, it's balanced. Yay, we're done. So in a question you might see on a test or something like that, or when you move on to a 30 level class, they might ask you like in a bubble sheet, like, how is it balanced? Well, it would be 1, 2, 1, 1, right? If there's nothing there, then it's a 1. Don't say it's a 0, okay? You don't have to put the 1s there, but I'm just putting you to the future. You might see like a multiple choice question that might go like, well, it's 1, 2, 1, 1, or something like that, right? Just to get you in that mindset, all right? Easy, bring you back memories of fun times balancing equations. It's my favorite. I love it. I think I always start with chemistry because it's my favorite, even though I have a biology degree. Okay, anyway, moving on. So there's some practice ones here. It says balance each of these. Does it give you space? Do you want to do them together or do you want to try them on your own?
That's it, do them together.
Do them together?
No use to do them
Okay. How do what's I do? Can I make space? No. This is just a picture.
The only thing good for breakfast is the jam.
Did you just eat jam?
That's what I'm eating right now.
ZnCuSO4, ZnSO4, Cu. Okay, I have to make a new slide for this, sorry. Zn, that's not an N. This is a little bit more complicated one. So it's a good example to do. Or maybe not. Yeah. Maybe not, never mind. But I am going to show you just a really quick, it is already balanced, so Janae's like, wait, it's not, it's a really easy one because it's already balanced. But what I want to show you is, some people might break this apart into its elements. So they might go, oh, there's an S, and then there's an O. And then when they started to tally these up, they would say there's 4 oxygens and 1 sulfur. So you could do that, but what I'm going to show you is that as long as these SO4 is together on the other side, it still stays as SO4, you can just balance it together. That's actually a polyatomic ion. So if you had H2O on one side of your reaction and H2O on the other, when you're doing this, you could just write H2O, right? Because really you're balancing, the molecule hasn't changed, so it's on both sides. You don't have to split it into H's and O's or S's and O4 O's. Okay? So yeah, Janae saw it and I didn't see it before she did, so I was like, this is going to be a harder one just because I was looking at the fact that I wanted to show you that SO4 you could balance together. They're all one, so we don't have to do anything. There's no numbers we need to add, it's already balanced. Good, easy question, complete. All right, so that's not a good question at all. Is the next one? The next one's not balanced. So Fe, HCl, FeCl3, and H2. So we've got iron and hydrochloric acid, and that is mixed together to create iron chloride, iron 3 chloride, and H2. So my method, draw a line down the middle, tally up what we got, so write down all the elements. Unless you can write molecules if they're the same on both sides, we can't because the H's don't stay with the Cl's. So break it into Fe, H, and Cl. Tally up what we have. What do we got? Fe, how many?
1.
H's, Cl's,
1.
Fe's, H's, Cl's. Perfect. Okay, what do we do? Where do we start?
Skip the H's and O's.
H's and O's? Oh, we end with H's. Okay. I was like, there's no O's here, guys. You're just saying the rules. Yes, good.
We start with the Cl.
Perfect, yeah. Because the Fe's are balanced, so let's start with the Cl. So our chloride is 3 on the right, 1 on the left. So we got to make this a 3. What do we do?
We definitely don't put 3 there.
Why are you doing that? So we put a 3 there. If we put a 3 in front, that's going to say there's 3 Cl's, but what that's also going to do is it's going to make 3 H's. Are we messed? Is this not good?
No.
It's not good. There's a major problem.
Now we have 3 H's on that.
We got 3 H's. Can we ever get 2 times something gives us 3? Because the lowest number we can put here is 2. Well, 2 times 2 is 4, right? So we're never going to be able to get 3 H's. Go back to the drawing board. What the heck? They must have put down. Wait, this was H2? Alright, so I'm gonna start over. I can't, this isn't very precise. Alright, so we can't put 3 there. because if we do, then it'll mess up our H's. So what I'm going to consider, and maybe this is wild, but since the 3 didn't work, what's the next multiple of 3 we could use? Yeah. So let's try 6. I know it's crazy. We tried 3, didn't work, let's put 6. So if we put a 6 there, that makes our H6 and our Cl6. So now we can possibly make this work. So if our Cl is 6 on the left, what do we got to put in front of here to get 6 Cls? 2. So that helps our Cls, they're now 6. That also affects our Fe's. What's our irons now? 2. Yeah. Okay. You know what? We can balance our Fe's or our H's, doesn't matter to me. Which one do you want to do? Fe. Okay, so it's 2 on the right. We need 2 over here. So to do that, we just put a 2 there, right? Now our irons are balanced, our chlorides are balanced. We just need our H's. 6 on the left, 2 on the right. There's a little 2 at the end, so we know it's going to be 2 times whatever we put in the front. So 2 times what gives us 6?
Definitely not
3. There we go. Balance. Wow, we accomplished it. Yeah. So sometimes in these you'll run into like a little trouble. Don't get discouraged. Just, it's always going to be with that H2. It like almost always is. Like sometimes you'll see one that has 3 H's on one side, and it's like, well, I'm never going to be able to get a negative or a odd number with a 2 times something, right? So then you're just going to have to put a 2 in front on the other side, and like 2 times 3 will give you 6. Now it's an even number. Now we can get there. Okay, so I believe in your guys' like math skills and seeing this that you'll be able to figure it out. And if you get stuck, let me know. Even when you're at home, if you're trying these and you're having trouble, just send it to me in a text or send it to me on email. Since like this week, a cohort 1 student has been sending me texts and pictures of an assignment. She like writes it and she takes a picture. No, it's me this. No, just
Alyssa probably hasn't sent anything.
well.
He's probably at home.
Okay, Alyssa can hear you right now, so let's not bash it.
Oh, I'm sorry, Alyssa.
If he looks at his assignments.
Hey, you bashed him too.
Oh no. Yeah. Well, Alyssa actually do his work. You would have to watch the video. Sorry. Okay, we love you, Alyssa.
It's not me if you hear this.
Let's do the last one. It's not live, so once I upload it.
Yeah, it's not me.
Okay. Let's do the last one. It might be throwing us for a little bit of a loop here. There seems to be quite a big molecule. What the heck? Why would it be Al2SO4? That doesn't make sense. Did I write this down wrong? No. Yeah, I did. I messed up, but I don't know what I did. Oh. That's a 3. That's where I messed up. Okay. Does someone want to do this?
I'm good right now.
No? You're just going to tell me?
Yeah. I don't have that.
What do we do?
Definitely don't put a line to me.
Can you stop with that? You're making me crazy. I'm already crazy. Because I'm pouring water in Janice. Saying what she pictured it. What do we do now?
Mark down all of the elements.
Yeah, write down all the elements or the ions.
Yeah.
Because SO4 is on this side and this side, so we can keep it together. tally up how many we have. ALs, 1, CUs, 1, SO4s, 1. Some people in Science 10 might have said 4. That's SO4 goes to the oxygen, that goes, it's just saying how much of that molecule. If there was more SO4s, we'd have brackets that would say how many are there, which we do on the right hand side. ALs on the right, 2 CUs, 1, and SO4s, 3. So that 3 is saying there's 3 of everything inside that bracket. Now we can balance it. CUs are already balanced. We can start with ALs and we can start with SO4s. Doesn't matter. You can see that it's not going to cause us too much trouble. Which one would you like to start with? SO4s. So we got 3 on the right, we need 3 on the left. So what do we put in front? Right here? 3. That gives our SO4s to be 3. It also changes our CUs to be 3. Let's balance our CUs. There's 3 on the left now. We need 3 on the right. We can put a 3 here. And now it's balanced, right? Good. So our coppers are good, our sulfates are good. We just need our aluminums. 2 aluminums on the right, 1 on the left. Put a 2 here, and you're good. 2, 3, 3, 1. Good. Yeah. 1.
Hope we get Jack lunch too.
Okay, I'm gonna go through one more thing, and then I'll give you maybe a little bit of time to do some work. There is some balancing on your topic 2 review. And then on number 3 it goes to this. Yeah, I'll go over what a mole ratio is right now, and then I'll finish off that for that today. So mole ratio, what is it? It says in addition to balancing the equation, the coefficients are these things. These numbers that are in front of the molecules. They indicate the relative ratios of one compound to another. The ratio of these coefficients is referred to as the mole ratio. The mole ratio of a particular reaction tells us how many of each molecule must be present in order for the reaction to occur. So consider this example. If we're looking at a ratio, really what they're meaning here is we could be like, how many silvers are there to silver sulfides? So if you were going to do a ratio, you would be like, oh, there is how many AGs to AG2S? If we were going to do a ratio, we would just say 4 to 2. Does that make sense? So you're just taking that number that's in the front of that element and putting that as your ratio. So this is what it says here. For every 4 atoms of silver, there are 2 molecules of silver sulfide. Thus, the mole ratio is 4 to 2. Yeah? Good? Okay? Hi? You're good? No? It's written right here in these words, but you can write it there if you'd like. It seems like pretty simple right now. Maybe? No? But you're going to use these ratios to do some calculations later on.
Yeah.
And you've done ratios at open math at one point, like you know, like a number with like a colon to another thing, that's a ratio. Yeah? Yeah? Yes, I hope. Think of like science in high school as like using some of the things you learn in like middle school math or junior high math, right? It wants to make sure, or hopefully that you had to figure those out or remember them. we're going to review back to them. We're not doing like really difficult math in science class, just like junior high math with science involved. Okay, one thing I want to just review to you and maybe write down here, since this is my junior high math. 4 to 2 is a ratio. How can I write that ratio as a fraction?
No, I didn't.
4 over 2. You don't want to flip it. I know you don't, maybe we don't like improper fractions when there's like a higher number on the top, but that's how you would write it as a fraction. Why I'm doing that is because when you do your calculations, that's how you're going to write it. You're going to write it like there is 4 AGs to 2 AG 2S. Okay? So knowing that this is what we're going to be using ratios, that's what it's going to look like. Okay? So we're just doing it like that. So if we had a number, it's basically going to be multiplied by 4 and divided by 2. They're using that as, or that's how we're going to be using ratios. Okay? And it will explain that over here. So let's go over one of these examples and then we'll finish here. It says, how do we apply the mole ratio? We do. And if you take like Chem 20, you're going to do this to your higher mole ratios. It says the ratio of compounds involved in a chemical equation can be used to determine how many moles, they use the letter N, of each substance are present. So consider this reaction once again, and then they're going to give us a question. So it says, if 0.876 moles of silver sulfide are produced from a reaction above, how many moles of silver were required for this reaction? So we use, I guess, this formula. We just take the number and multiply it by our mole ratio. I'll write it on this side. It does explain it there, but I like to go through it step by step. So if they give us a mole rate number, 0.876 moles. And it's really important that you take note of what element that is. Ag2S. Okay. To figure out how many moles we would need of silver, all we got to do is multiply it by the mole ratio.
Is that the equation of
This?
Yeah.
Yeah, this is telling you how to do it. So I know I need more space. I guess I can write it down here. I forgot it. Sorry. Yeah, so this is the equation here. It says the amount of moles that we have of the thing they've given us in the question, so Ag2S, times by the coefficient of the thing we want, divided by the coefficient of the thing given. So they gave us 0.876 moles of Ag2S. We're going to multiply it by our coefficient of wanted. So what's the thing we want? The question's saying how many moles of Ag. So Ag is going to go on the top. That's what we want. What was given to us is Ag2S. Okay? So once we use that formula, that tells us exactly where we need to put which element goes where. How many Ags do we have? Well, we've got to go back to our equation, or our balanced equation. So how many Ags do we have in the balanced equation? 4. So this 4 is coming from right here. Okay? And then Ag2S, how many do we have of that? 2, right? So we put the 2 there. Now all we gotta do is do the math. So we just put 0.876 multiplied by 4 and divided by 2. If you would rather do this as this and then put this in brackets in your calculator, 4 times by 4 divided by 2 in brackets, whatever you do, it's going to come out with the same answer. Okay? So this multiplied by 4 and then divided by 2. It'll give you our answer, and the answer, it gives you it up here. I hope I got the same answer. 1.752. Perfect. So what are we trying to figure out? What does this all mean? It says how many moles of silver do we need. So this should be, the number's good. We really need to write our units. It's moles. And what is it moles of? Silver. Is that a lot to comprehend? This is a new concept. You never learned it before, I don't think. Maybe you may have, but could have been a long time ago. So it's using these balanced equations to figure out how much we need, or how much of that chemical we need. So that's what our balanced equations give us. That's our mole ratio. Is there another example I wonder?
I don't think so.
Well, they give you I love how they give you the formula afterwards. I'm just going to go back to this for a second. For me in my head, I never need to know a formula when I'm doing this. And why? And this is something my teacher in high school taught me. Whatever we have, we want to get rid of it. Did you ever learn about like crossing stuff out or canceling?
Yeah.
So if we have Ag2S on the top and Ag2S on the bottom, like them divided into each other, that cancels. So whatever I have on the top, I always put it on the bottom to cancel, right? We cancel those out, now we're left with Ag. That's what we need. We need Ag. Alright? That's what I do in my head. I'm like, oh, if it's on the top, we need to put it on the bottom here to cancel. You don't have to remember that. You could just always go back to this formula. Whatever makes sense to you. It's the same thing. This is telling us what we need. Our coefficient we want divided by the one that's given. That'll give us our answer. Okay. So when you're doing the topic 2 review questions, like refer back to these notes, like these give you your formulas. I should really create you a formula sheet. That would be nice of me.
Yeah.
I will do that. I'll add that to my list on your Janae Chromebook and Science 20 formula sheet. Because I don't think I gave them a formula sheet last year, just the Science 30 data bullshit, but I should create one for you guys. Okay. So I think that just want to check to see if that's it here. Oh, they gave us another practice problem. Would you like to do the practice problem? Thank you. You think you're good enough, Pat? Or you want to do practice? Do a practice? Yeah, we still have like 20 minutes till lunch, so we can do a practice. Is that okay to me?
Practice will help us.
Oh wow, this practice makes you balance it too. Isn't that nice of them?
Yeah, they're so nice.
They're so nice. Okay, so I'm gonna rewrite this equation down here, and then I'm gonna scroll up, just so that I have space to do my little tallying up on the bottom. They don't normally give you that space because they don't care. And maybe they can just do stuff in their head, but not me. Is it balanced? It's not, yeah. So if we tally up like we did before, we just got ALs and O's. So it's a simpler one, but our ALs on the left are just 1, and our oxygens 2, right? How many ALs on the right? 2, and oxygens 3. Okay, So this is leading us to one of those questions, but just by looking at it, I can see on the right-hand side, there's a 3 on the oxygen. There's a 2 on the oxygen on the left. 2 times something will never give us 3, right? So what I'm going to do, I'm going to put a 2 in front of this, because that's going to change our oxygen to 6. Now that's an even number that we can get over on the left. What that does to the aluminum, how many aluminums do we have now? 4. Perfect. Can we balance it now?
Yep.
Yeah. So our oxygens, we need it to be 6. 2 times what gives us 6? 3. And then we need a 4 aluminum on the left, so we just put a 4 here, and that becomes 4. Alright? So that's balanced. That's one of those ones where you just gotta look at it and be like, okay, I can never multiply 2 by something to give us 3. Just make that 3 an even number by putting a 2 in front. And it normally solves your problems. Okay, can I'm gonna write this up here because we've done it. 4, 3, 2. And then I'm just gonna erase this. Is that okay? You can
Yeah.
see it if you need to, but I think you guys are good. So we've got it up in the top equation, so now we can use some information here to do our calculations. It says, if 6.25 moles of aluminum are present, how many moles of aluminum oxide will be formed? So, let's do this one. So I'm going to write down what they give us. 6.25 moles, and it's of aluminum, so Al. To figure this out, we need to use our mole ratio. What goes on the top, what goes on the bottom? If you look back to the formula, it says what's wanted is on the top, and what we want, how many moles of aluminum oxide. So that's what we want is on the top, so Al2O3, that's aluminum oxide. So what we have goes on the bottom, which is Al. Now, we just put in the ratio that we got by balancing the equation. Al2O3, 2, right? How many ALs? 4. Then we just calculate. So we go 6.25 times 2 divided by 4. Did you already do it? No? Okay. They're sitting there like, yeah, I know. So if we calculate that, 6.25 multiplied by 2 divided by 4, I get 3.125. And what is this? Well, we're looking at moles. It needs to be moles, and it's moles of this. Al2O3. Okay, so that's our answer. Can't really do a box around it. The last one says how many moles of oxygen are required to react with 6.25 moles of aluminum. Alright, so we're doing another ratio using the exact same starting number. So we're starting out with 6.25 moles of aluminum, and we're doing a new ratio. So we want to find out oxygen. So what we want is on the top, that's oxygen. What we had is on the bottom, that's aluminum. We go back to our equation up here. Oxygen, 3, right? Aluminum, 4. Then we calculate. So 6.25 multiplied by 3 and then divided by 4 gives us 4.69. That it actually came out to 4.6875, but I would like to keep 2 decimal places. I should have done that up here. Man. yeah, I'm changing now into 2 decimal places. So I got 4.6875. And then I rounded it to 2 decimal places. Remember that that is moles. The units are very important. And what is it moles of? Oxygen. Okay. So those are 2 examples for you. Some examples. I think you guys, are you getting it? Yeah? Makes sense? Yeah. Perfect. That's good. That's makes me happy. So hopefully the online people do it as well, but if you have any questions, let me know. Yeah, I'd like you guys to work on your topic 2 review. We've done up to, you can probably at least do up to 3 now. We've gone through that, so that's what you would have to do until Monday or Tuesday when we continue on this, okay? So all you we've done so far up to number 3 on topic 2. Try and finish topic 1 as well. If you haven't,